Morning to one and all. I am Parthiban working as assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called electron devices, which is coming under the regulation R 2025. The subject code is EC25C01, which is meant for second semester ECE students. Now I am going to talk about the unit 4, which deals with JFET. Earlier we have seen a JFET with its introduction. Now a JFET is a device which is a voltage controlled semiconductor device, unlike BJT which is a current controlled. So voltage at the gate is used to control the flow of the current in the device. So FET is a unipolar device because here the current conduction takes place only through majority carriers. For example, if it is a n-channel JFET, the electrons are the majority carrier that plays a role. If it is a p-channel JFET, then holes are the majority carriers that plays the crucial role. JFET has three terminals, one is gate, the other one is drain, and the next one is source. So the gate controls the current, gate is reverse biased, gate current is almost zero, we can see. A drain is the one where the current leaves the channel through the drain. It is connected to positive supply in the n-channel JFET. Source is the terminal where electrons enter through the source, usually connected to the ground. Then VGS. VGS is nothing but the gate to source voltage. This controls the width of the conducting channel. Generally, more negative VGS sheets applied for N channel. So narrower the channel, smaller the drain current. So VDS is there, that is nothing but the drain to source voltage. It provides the driving force for the current flow. ID is the current flow from the drain to source. It is mainly controlled by VGS. So these are the various features that we have to kept in mind before going into the JFET characteristics. Then coming on to the transfer characteristics. What is a transfer characteristics? It is a characteristics that is defined between one input parameter and one output parameter. Here we are taking the input voltage, that is VGS, as one parameter, and we are taking the output current ID as the second parameter. So the graph now will show the VGS how affects the drain current. So the transfer characteristics is basically based on the Shockley's equation. So based on that only we can have the equation. So when VGS is equal to 0, then ID is equal to IDSS, we can say. Then that maximum current will flow at the time. In the case 2, when VGS becomes more negative, the current decreases and the current becomes smaller than IDSS. In the case 3, we can say that is when VGS is equal to VP, that is pinch off voltage, the current becomes 0 and the device is kept in the off state. So the important applications where we can use this JFET is it can be used for amplifiers, it can be used as a switch, it can be used as a voltage controlled resistors or voltage variable resistors. So these are the observations that we can make. So we can have the characteristics when VGS is equal to 0, ID will become IDSS, that is called maximum current. When more negative VGS is applied, the current gradually decreases. When VGS is equal to VP, the current becomes 0. Though we can see from the diagram the output characteristics, that is the drain characteristics versus the drain voltage characteristics. For different VGS we can have different values. So the saturation region, we can say it is nothing but a pinch off region, or it is also called drain current becomes constant region. So the JFET acts as if like a constant current source. So there are some observations that we have made about JFET. Now we are going to enter about the MOSFET. So what is MOSFET? MOSFET is an extension of JFET. It is also called as metal oxide semiconductor field effect transistor. It is also a voltage controlled device. So compared with the JFET, it can be operated in two modes. That is called, one mode is called depletion type MOSFET. The another mode is called enhancement type MOSFET. MOSFET in comparison with the JFET has the following advantages, namely it has a high input impedance, it has a faster switching, it has lower power consumption, it is very easier for fabrication. That is why MOSFET has become more popular. So here, based on the gate bias, we can classify depletion type and enhancement type. So the drain and source are connected to the N-doped regions. The N-doped regions are connected via N channel. This N channel is connected to the gate via a thin insulating layer, SiO2 layer. This SiO2 layer provides a very high input impedance for the MOSFET. So MOSFET is comparatively more popular than JFET because of its features. It is very widely used in microprocessors, RAMs, and laptops and other power supplies. So both modes are very popular, both diffusion mode and enhancement mode. So based on the gate bias only, we can say it is operated in diffusion or it is operated in enhancement mode. So this is the typical characteristics that shows when the gate bias is negative, we can say it is in depletion mode. When the gate bias is positive, we can say it is in enhancement mode. So from the graph, you can observe the variation in the characteristics of MOSFETs. So the only thing that is difference with the JFET is JFET can be operated in only one mode, whereas your MOSFET can be operated in two modes, namely the enhancement mode as well as in depletion mode. So that is the biggest advantages. So the other very much advantages are the very high input impedance, very low power consumption, and very high speed switching, and easily integrated with the IC technology. So these are the greatest advantages of MOSFET. So why we go for MOSFET can be observed from this. These are the various references that I have made. Thanking you one and all for hearing my lecture. Once again, thank you very much.